Here, the possible solutions for p are between negative 2/3 and positive 1/3. Now that's amazing problem solving if you got this one correct. To start this problem, we want to subtract 2 from both sides of the inequality. This gives us a quadratic expression on the left and 0 on the right. Now we want to find the zeros, or the values of p, that make this quadratic expression equal to 0. We find factors of negative 18 that sum to positive 3. Those two factors are positive 6 and negative 3, and we use them to rewrite the middle term of plus 3p. Using factoring by grouping, we get the factors 3p plus 2 and 3p minus 1. Next, we set each factor equal to 0, and then we solve for the values of p. So p could equal negative 2/3, or p could equal positive 1/3. Next, we use our two zero values to create 3 different intervals. And now it's just a matter of testing each one to see which ones are part of the solution. For the first interval, we'll plug in p is equal to negative 1. When we plug in this value for p, we'll get the statement 4 is less than 0. We know this statement is not true, so we exclude this interval from our solution set. For the second interval, we'll test the value of 0. We know 0 is in between these two fractions since one of them is negative and the other one's positive. When we plug in p equals 0, we get the statement negative 2 is less than 0. This is definitely true, so this part is part of our solution set. For the third interval, we'll test p equals 1, and we'll get the statement 10 is less than 0. We know this is false, so this is not part of our solution, which leaves us with this interval only. Any value between negative 2/3 and positive 1/3 will make our original inequality true. We also use parentheses here and in our interval notation since this is just a less than symbol. We can't be equal to 0.